This lesson is from Mrs. Cucci's College Now Pre-Calculus class. We are picking up where we left off in this matrices lesson. Today we're going to be talking about how we find inverse matrices. So please make sure that you have plenty of space. This probably will take an entire page, so please make sure that you have a whole notebook out in front of you. So matrix A is the matrix 1, 2, -1, 3, 5, 3, 2, 4, 3. And what I want to do is I want to take this matrix and I want to find its inverse. So the way we have to start this is actually by setting up a augmented matrix. So that augmented matrix, the left-hand side is exactly what it is originally. And the right-hand side is your identity. Okay. So the way we go about finding the inverse matrix is we want to get that left-hand side of the matrix to look exactly like the right-hand side. And we're going to have to use matrix operations to do that. So let's start by trying to turn this 3 into a 0. Okay, that's our first step. So one of the ways that we can go about doing this is by taking a look at row 1. If I take row 1 and I multiply row 1 by a -3, what I would be able to do is then add row 1 and row 3 together in order to get that 0 in its place. Okay, so this is that elimination that we've been working on the past couple lessons. All right, so when I multiply this through by -3, I get -3, -6, 3, -3, 0, 0. Now I've got a tight squeeze here. 3, 5, 3, 0, 1, 0. Apologies, a little too fast here. And then 2, 4, 3, 0, 0, 1. Okay, so like I said, we want to get that 3 to be a 0. So what we can then look at is these two rows here. If I add row 1 to row 3, that 3 will cancel out. Okay? Remember that once I do this, that row 1 does go back to its original. That row 1 goes back to 1, 2, -1, 1, 0, 0. I'm now adding these first row and the second row together, which is going to give me 0, -1, 6, -3, 1, 0. And then that third row is exactly what it was before, hasn't changed. Okay. So the next thing that we want to try and adjust, you could really start anywhere. There's no one way to do this. So I'm going to go for that 2 there. I want to make that into a 0. So one of the ways in which I can do that is by taking, again, a look at row 1. If I multiply row 1 by -2, I can then add row 1 and row 3 together. Okay? So I'm doing -2 times row 1 in order to get -2, -4, 2, -2, 0, 0. Row 2 has not changed. Oops. And 3 has also not changed. It will momentarily, but it hasn't yet, right? So now that I have that, I can look at this row 1 and row 2. If I add row 1 and row 2 together, we'll get that to cancel. And again, that row 1 going back to its original state. Row 2 has not changed. Now I'm adding row 1 and row 3. I don't know why I wrote row 2, because I've been doing this all day. At row 3, I apologize. Okay, so I'm adding these two rows together right now, and that's what's going in as my new row 3, right? So I get 0, 0, 5, -2, 0, 1. Okay. So I'm on a good roll here. I've got those 3 zeros, which is awesome, but I want all that these diagonals to be 1, right? So let's work on that 5. What could I do to row 3 to make that into a 1? Well, I know I can multiply that by a 5th. Multiply the whole row through by a 5th. So I'm going to multiply row 3 by 1/5. Okay, if I multiply row 3 by a fifth, what I get, right, row 1 doesn't change again, row 2 doesn't change, and row 3 becomes 0, 0, 1, negative 2 fifths, 0, 1 fifth. Okay, so we're getting closer here. All right, well, this actually set me up nicely because if I look here and here, I know that I can make this negative 1 into a 0. And all I have to do there is add together row 3 and row 1. And notice the order in which I'm writing this, row 3 plus row 1. Row 3 comes first because that's the one that's going to go back to its original. Row 1 comes second because that's the one that's being changed. Okay, so when I add these together now, I get 1, 2, 0. 3 fifths, 0, 1 fifth. Row 2 has not changed. 0, negative 1, 6, negative 3, 1, 0. And then row 3 hasn't changed. Okay, so we're on a really good track here. Okay, all right, so let's talk about what to do next. We want to get rid of that 6, right? I'd like this to be a 0. The only thing I have to work with here is that third row. If I take row 3 and I multiply row 3 by negative 6, I'd then be able to add rows 2 and 3 together in order to get that to cancel, right? So let's go ahead and multiply row 3 by a negative 6. So we get 1, 2, 0, 3 fifths, 0, 1 fifth, nothing's changed there. 0, negative 1, 6, negative 3, 1, 0, nothing's changed there. 0, 0, negative 6, 12 fifths, 0, negative 6 fifths. Remember, that third row is going to convert back, right? So now we're going to add row 3 to row 2, here and here. Okay, so when I add these together, row 1 does not change again. So now I'm adding row 3 to row 2. And we get 0, negative 1, 0, negative 3 fifths, 1, negative 6 fifths. And then 0, 0, 1, right? We're converting back to our original, negative 2 fifths, 0, 1 fifth. So I'm close, but I'm not quite there yet, right? So I am going to need more space, which means I am going to have to pause here and do some rearranging. So please make sure you get all of this down, and we'll pick back up in just a second. Okay, so we're going to continue from here. So now what we need to look at is maybe working on getting rid of this 2. Okay. I think maybe the easiest way to get rid of that 2 would be to multiply row 2 by through a 2 so that we could add 1 and 2 together. So we're going to do 2, row 2, which is going to give us, this is in my way, 1, 2, 0, 3 fifths, 0, 1 fifth, 0, negative 2, 0, negative 6 fifths, 2, negative 12 fifths, 0, 0, 1, negative 2 fifths, 0, 1 fifth. Okay. So now that I have that, I can go ahead and add together row 2 and row 1. So when I'm adding together row 2 and row 1, I wind up with 1, 0, 0, negative 3 fifths, 2, negative 11 fifths, 0, negative 1, 0, negative 3 fifths, 1, negative 6 fifths, and then and 0, 0, 1, negative 2 fifths, 0, 1 fifth. All right, so I only have one more piece left to do, and that's to work on this value of negative 1, right? I want it to be a positive 1. Super easy solution here. We're just going to multiply row 2 by a negative 1. Okay. When we do that, row 1 stays the same. Row 2. And row 3. So now that the left-hand side is that identity matrix, what I have found is the inverse. Okay? So the inverse of matrix A is negative 3 fifths, 2, negative 11 fifths, 3 fifths, negative 1, 6 fifths, negative 2 fifths, 0, 1 fifth. That's your inverse matrix. So I know that these are long. I know that they're a lot of work. They do take practice, so you just kind of have to keep going with them. There's more than one way to do them. Not everybody's going to have the same step in the same order, and that's fine, but you all will eventually come to the same end product. Okay. All right, so, whoops, sorry about that. Okay, so how can we go about solving systems of equations? Can we write a system of n linear equations and variables as a matrix equation, ax equals b? If A has an inverse, then the system of equations has a unique solution that can be found by solving for x, such as. So if I have ax equals b, okay, I take the inverse, what we wind up with A inverse and A, right? That's your identity. And that's one of the rules we learned in the last video. And the identity times anything is itself. So we wind up with this. Okay, so that's just kind of like the generic how things work. So if I do take the inverse of a function, I wind up with that variable of x. Okay. All right, so let's actually do an example of that. Since matrix multiplication is not commutative in general, you have to be careful when you multiply on the left by A inverse. Okay. So what we're going to do is we're actually going to set up my matrix here based on this system. So it's negative 2, 3, negative 3, 4, right? And then my variables, x, y. What am I doing? X, y. And that should equal 4, 5. Okay. In the last video, we already found the inverse of this matrix, so I'm not going to redo the whole thing because that's a lot of work. Okay, so we wind up with that as our inverse. So based on our rule, the inverse function, or the inverse matrix, okay, we can go ahead and just multiply those together based on our rule. All right? So when we multiply these together, we actually wind up with solution 1, 2. And you guys should by now know how to multiply matrices, so I'm not going to go over that multiplication. If you're unsure of how I got that, we can go over it in class tomorrow. But again, you guys should be pretty comfortable with multiplying matrices by now. Okay? First row down the first column, second row down the first column, because that's all we have. Okay? So that is it. Make sure you come prepared with any questions, and I will see you tomorrow.